Hello, my name is Crystal Contreras, and this is my milestone for SE456. The first pattern we'll be discussing is the adapter pattern, which wraps an existing class with a new interface. In this case, our texture class wraps the Azul texture class. That way, in case there's any breakage or we need to change anything, all we have to do is change it in our texture class, and it'll fix it throughout everywhere else that texture is called. The next thing that we are going to talk about is the template pattern. And so the template pattern has a manager base. That manager base is our template. It's like a skeleton code that can declare and define general methods and have placeholder methods. And so the class such as the sprite batch manager, the sprite node manager, and the sprite manager all inherit from the manager base. That way we can reuse some of those methods. So the manager base gets called by these managers from the texture manager all the way down to the sprite box manager. Okay. So here it is in our sprite manager, which also has a add implementation, create, and destroy. So our sprite manager is also a singleton pattern, and so is our sprite box manager. All of these are singleton patterns that also inherit template patterns. And in our sprite box manager, we create reserves and initial activation reserves. And here we are creating an instance of it, which also calls our pattern to create our sprite box. So this singleton pattern we only have to instantiate it once, and it's better than having global variables because it consumes less resources. In our game object node manager, we create a new game object null. So in here, we call the game object name null. So by having a null object, this pattern provides an intelligent way to do a nothing behavior, which hides the details from its collaborators. Next, we have the alien factory example. So the alien factory basically churns a lot of objects. It acts as a surrogate to impose a It is a pattern that instantiates and creates a bunch of objects for us. It increases cohesion and it loosens up coupling. So here we are creating an instantiation of our alien factory, and then from there we can create our alien grid and our alien columns, which are instances of composites, a composite pattern. So here we are creating the grid. The grid, as you'll see, is derived from a composite, and a composite is derived from a game object, and our game object is derived from a component, which is used, which also derives from a D-link. So you'll see here that it basically shows our composite pattern. Here, I'll give you a little composite diagram. So our component class gets inherited by our game object class, and then our game object class is inherited for our leaves and composites. And leaves have no children, but composites do. And in this case, it's our alien column and our alien grid. So the composite pattern is a tree-structured hierarchy, and it allows us to pass down updates easily and cleanly to all members. Here we are coming back down after setting everything. All right. So now, in our game object node manager, we just attach it, and we have our column factory creating more columns. For example, here, we call the new collision object, and this is a composite, so the composites have a pointer to a collision object, and this collision object takes in a sprite proxy. So proxies are placeholders for another object to control access to it, and it is a lightweight, which means it's less memory consuming option that allows us to point to a real object and acts as a wrapper that we can send updates through. So our game object points to a sprite proxy and passes updates to the proxies that we then get updated to our real sprites. So here we are, our collision objects point to and own a collision rectangle, which our sprite box manager, then we add a sprite box to our sprite box manager for that collision object. Here we are passing it back up. All right. So the next pattern we will be discussing is the command pattern, which encapsulates a request as an object, and we use it to queue up the same move commands. So our texture diagram, game object diagram, you can see here in our command diagram that in this example I will be showing the move command that I implemented, because it also shows how we use S-links to inherit to the game node object, and then also the priority queue. So a command encapsulates a request as an object, and what we do here is we, create a game node object. Well, we find it, and then we are going to send it to our single link manager, and this is going to allow us to then attach a command that we want. So for this one, this is the step that we use for the aliens to march. So we set the new X and Y coordinates, we add it to the front, and we update the iterator. So then we are going to use our timer event manager, which is an example of the priority queue pattern, because we use a priority queue in our timer event to sort the list. That way, for the timer events, the events that come in get processed in first come, first serve order, depending on the time. Whichever one gets triggered first will get called first, and then if we pass the current time that's for checking against other timer events, then we can just break at that point. So, for example, here we set our timer event, and this is the trigger time, so I've mentioned. And here we are setting the priority. And then once the priority is set, we are going to reorder our priority list. So we'll remove that newly added node, which is added to the front. That way it doesn't take up too much time to get it. And then we add by priority, and this is our implementation of the priority queue. Okay. So, and here's again the diagram. All right, so second to last, we are going to talk about the draw methods. So while that's going on in the background, the draw method, right here for our sprite batch manager, 11. Let's just put a breakpoint right there. All right. So as we walk through the draw manager, you'll see that this is actually an iterator pattern, and it's a way to access elements of an object sequentially without exposing its underlying representation. This allows us to decouple collection classes. So we get our iterator, and we grab the first one, and that's either the head or it's not. And we have a Boolean checking if the iterator is done. And while that iterator, while we still have nodes in the list, we call our draw method per element, which also has another iterator inside itself, in this case in the sprite node manager. And inside here is where we render the actual images. All right. So you'll see the marching, you'll see the grid and the columns and the aliens have their boxes surrounded by them. And the last thing that we're going to talk about is object pooling. So it'll pause when it's there, but for now we will look at the diagram for the image diagram. So object pooling allows us to reuse resources, saving us from performing computationally expensive performance, such as creating new objects. So our image pooling here, we have a double linked list with nodes, and these nodes, we have the image nodes here. And these image nodes we are able to reuse. So when this gets to the edge, it will call our image node manager, which will remove 2 of these characters and be replaced with birds, as you'll see. What's going on here? Oh, it did pause. Okay. So here we are removing it. We remove our image here in our remove method. Again, it's a singleton because it's a manager. So we remove our node from our active list. We clean it and we add it back to our reserved list, and we update our stats. So we're going to remove the crab images, and we're going to replace them with birds. And here we are adding it back into our active list. We remove from the front of the reserve list. We clean it. We add it to the front. We update our stats. We set the node, return the node, and now we should have birds instead of goods. And you'll see that they are moving back over to the left. Usually it doesn't go that far to the right, but I think it got the screen display got changed up a little bit. But here you go, and thank you.